Darmic, do you own a car?
Yeah, it's that one right there.
But do you know how to change your own oil?
No, man, I live in a big city, so I just take it to a mechanic.
That's crazy. You could be saving hundreds every year if you just learn how to do it yourself.
Don't fret, we're here to help. Changing your oil is an easy task that can take less than 20 minutes, but you're gonna need car ramps.
But why is that? Well, a ramp is something that raises the front of a car up off the ground so that a human can go underneath to do various maintenances, including an oil change. These ramps take on many different shapes, sizes, and materials. This is what we'd like to talk to you about today.
Okay, well, here I have a steel ramp from home. Let's take a look.
That could work, but there are some issues with it. Looking from your material science background, what can you see?
Well, I can see that it is heavily corroded, which may have compromised the material's properties. As it is an older ramp, its shape and size are not ideal for the safety standards we like to follow as mechanical engineers either.
That is true. Before we begin, let's first look at the ramp that we have. Do you know the exact type of steel that it is made of?
Well, looking at some online sources, mild steel is generally the most common type used for steel car ramps. The most common type of mild steel is A36, which has an elemental composition of 0.25 to 0.29% carbon and 98% iron.
Do you know about any heat treatments on this part?
Well, because the part is old, over 20 years old in fact, it was probably made of hot rolled steel. It involves heating the steel past its recrystallization point before being flattened and formed into the required shape. Cold rolling would be better for improving the strength, surface finish, and geometric precision of the part, but hot rolling is cheaper, so these benefits are not worth the extra cost to manufacturers for steel car ramps.
In general, though, for an A36 steel car ramp, you can undergo an annealing process, which relieves internal stresses and refines the grain structure. A schedule that can be followed is to heat the steel ramp to around 870 degrees Celsius and hold for 1 hour per inch of thickness. We can then slowly cool the ramp in a furnace to room temperature.
You can also undergo a normalizing process, which also refines the grain structure and enhances uniformity for improved machinability. We can heat the steel ramp to around 870 degrees Celsius and hold for 1 hour, like before, and then air cool the ramp to room temperature at a much quicker rate than before. These basic heat treatment schedules aim to relieve stresses and increase the durability of the material if needed.
Okay, so what are the mechanics and loading that this part undergoes?
The mechanics of a car ramp rely on its structural design and load-bearing capabilities. It typically consists of an inclined surface supported by legs. As vehicles ascend or descend the ramp, forces such as compression, tension, and shear stresses come into play. To further analyze its mechanics, we can use our knowledge from ME219.
I see. Well, firstly, we need to know the average load a car ramp can hold. From various sources, a pair of ramps should hold 6,000 pounds in total, or 3,000 pounds per ramp. Using this, we can draw a diagram as shown and find the force from the car. Using concepts of statics and equilibrium, we can sum the forces and moments to get the reaction forces from the ground.
Interesting. Using our design knowledge, we can make a SolidWorks model and run an FEA simulation of the forces to understand it further. As you can see, here we have a remade SolidWorks model of the ramp with modest simplifications. The material was set as A36 steel. Running a study, we set the bottom of the ramp to be fixed, and we applied a load of 3,000 pounds on the top, where the wheel would be. Obviously, the visual results shown are exaggerated, but its maximum displacement is 0.04187 millimeters, which is expected. This part should only elastically deform slightly since it is designed to hold the weight of the car.
Now for the corrosion. Corrosion is a common challenge in car ramps and can manifest in various key areas due to exposure to environmental elements and the stresses from the car. Typically, vulnerable sites include the exposed metal surfaces that meet the ground or encounter environmental agents. Areas where different components are welded or joined together also pose a risk as moisture and contaminants can penetrate these junctions, fostering corrosion. Looking at our part, we can see uniform corrosion all on the surface of the part, with it being more concentrated on the top where the tire touches.
I also think there could be some crevice corrosion at the bolts, which could benefit from a polymer washer. If the bolt is of a different material, it could imply galvanic corrosion. Moreover, since the part is undergoing a lot of stress from the weight of the car, stress-driven corrosion is also involved. There does not seem to be any evidence of corrosion mitigation. To mitigate it, you could add holes throughout the design to allow all the water to seep through. Water is a pathway to allow galvanic corrosion to occur, so not letting the water pool would mitigate the corrosion.
As mechanical engineers, we can also examine the sustainability of the part. By using an app like IDMAT, we can examine the eco-costs and carbon footprint of the ramp throughout its lifetime. As seen in the picture, the process of making the ramp has some negative impacts, but is also relatively inexpensive to manufacture and ship. In addition to this, the carbon footprint of the steel is significant, but could be reduced by using more closed-loop recycling. It is important to note, when looking at these figures, the numbers displayed are for the mass production of 500 ramps. If we just looked at one of these ramps, the values and impacts would be too small to visualize.
But now, we should look at how we can improve it. A good material to choose is PMMA, or polymethyl methacrylate. It is a polymer known for its durability and lightweight nature. As a polymer, PMMA doesn't undergo traditional heat treatments like steel. Instead, its properties are manipulated during the manufacturing process, allowing for various additives, shaping techniques, and curing processes. This flexibility enables us to tailor the material to meet our specific requirements for the car ramp, such as durability, weight reduction, and resistance to environmental elements, and especially resistance to corrosion.
Examining the mechanics of our new PMMA car ramp, its structural design is inherently the same as the steel. However, instead of using bolts and brackets, it is one large object. The ramp's incline and load-bearing capabilities don't change. The same ME219 principles apply as far as the reaction forces.
We can now rerun our FEA simulation with the new plastic material. As you can see, the new simulation has all the same conditions except for the material being changed to PMMA. The maximum displacement is now 3.197 millimeters. That is more than before. However, it is still acceptable. PMMA is the industry standard for car ramps after all.
Considering the corrosion for PMMA, we're looking at an advantage over steel. Being a polymer, PMMA is inherently much more resistant to typical corrosion seen in metals. However, it is not fully immune to corrosion. Environmental factors like heat, UV exposure, moisture, and certain chemicals can affect its longevity. Hence, we'll explore protective coatings or additives to enhance its resistance against environmental degradation.
Copper hydroxymethacrylate, or CHM, is an additive that can help protect PMMA from thermal degradation. A PMMA solution with just a 4% mass of CHM can significantly decrease the mass loss during a finished product's lifetime due to temperature fluctuations. The process of degradation is a chemical reaction that occurs. The additive increases the activation energy by more than 30 kilojoules per mole relative to pure PMMA.
Switching to PMMA also offers sustainability benefits. As a polymer, it allows for recycling and lower environmental impact during production compared to steel. By examining the eco-costs, carbon footprint, and recycling potential through the IDMAT app, we can gain further insight. IDMAT shows a decrease in spending for all aspects of eco-cost. The most significant change being to the landfill, as it is easier to recycle plastics than metals. In addition to this, the carbon footprint is much smaller as more recycled materials can be used, reducing the waste and carbon emissions.
So, today our exploration into the world of car ramps took us on an insightful journey. We looked at traditional A36 steel ramps, uncovering its heat treatments and mechanics. However, we discovered that corrosion, stress-driven degradation, and significant environmental footprints pose critical concerns.
To fix this, though, we can use a polymer like PMMA, which is lightweight, sustainable, corrosion resistant, and can be modified for extra environmental protection. Our FEA simulations confirmed its suitability as a replacement.
As we conclude this expedition, envision a future where engineering ingenuity meets sustainability, ushering in a new era of automotive maintenance solutions. So, Darmic, do you think you're still going to get your oil changed at the garage?
Absolutely not. I'm gonna go out and buy that PMMA car ramp as soon as I can.
That's what I thought.
Thanks for watching.